The problem is from GATE 2018 mathematics paper, question number 27. The problem given is the image of the half plane, real part of z plus imaginary part of z greater than 0 under the map w equal to z minus 1 divided by z plus I is given by the four options given are as option A, real part of w greater than 0, option B, imaginary part of w greater than 0, option C, modulus of w greater than 1, option D, modulus of w less than 1. So the four options given are, the NPTEL reference to solve this problem is lecture number 26 of Advanced Engineering Mathematics, and the title of this lecture is Bilinear Transformation by Professor P.N. Agarwal. He is from Department of Mathematics, IIT Roorkee. Even you can watch this reference lecture using this YouTube link. So now coming to the solution, it is asked to calculate the condition for the value of real part of w and imaginary part of w whenever we consider the condition for the z, that is real part of z plus imaginary part of z greater than 0. So by using this assumption that real part of z and imaginary part of real part of z plus w imaginary part of z greater than 0, we consider that function w. So firstly, let's assume z as the complex number x plus iy in C. Then let me write this. So then it is given that real part of z plus imaginary part of z greater than 0. That is x plus y is greater than 0, where x is the real part of z, y is imaginary part of z. Of course, this is the standard form of any complex number. So in that case, it is given that x plus y is greater than 0. And the map given is w as z minus 1 divided by z plus I. So now to solve this problem, we have to look at the four options given. So the first option is real part of w is greater than 0. For this, we have to calculate the real part of w, that is nothing but the real part of this function in terms of x and y, since the only condition we have is the condition x plus y greater than 0, that is in terms of x and y. So we have to calculate the real part of this function w in terms of x and y. Then we can see whether the option is correct or not. Similarly, when we look at the second option, imaginary part of w is also greater than 0. So for that also we have to look at the imaginary part of this complex number, this function z minus 1 divided by z plus I. So for that, since we have already assumed the standard form of the complex number z as x plus iy, so I just replace that z as follows. So we get x plus iy minus 1 divided by x plus iy plus I. This is the given function w in terms of x and y. So now for this, to look at the imaginary part and real part and imaginary part, I'm writing the numerator as x minus 1 plus I times y, and denominator as x plus I times y plus 1. So now to look at the imaginary part and real part of this function in terms of x and y, since we can look at in the denominator, there is both real part and imaginary part, with which we cannot decide what is the real part and imaginary part of this whole expression. So for that, what we do is we do the rationalization. That is, we just multiply with the conjugate of the denominator with in the numerator and denominator. Then we get, that is, we multiply this expression with the conjugate of the denominator as x minus I times y plus 1 divided by x minus I times y plus 1. So when we multiply this, it does not change any, it does not change the value of this expression, since it is nothing but we are just multiplying with 1. Since the denominator is non-zero, so we can do this thing. So in that case, we get the numerator as x minus 1 times x, the real part of real part as x minus 1 times x plus y times y plus 1, that is the real part of the numerator, plus I times the imaginary part is x minus 1 times y plus 1 plus xy. And coming to the denominator, since it is in the form of z into z bar, so we get this as mod z square, and that is nothing but x square plus y plus 1 whole square. So now this is nothing but a given function w. Now from this, we can easily look at the imaginary part and real part, this complex number w. So then we have real part of w as x times x minus 1 plus y times y plus 1 divided by x square plus y plus 1 whole square. Yes, correct. And imaginary part of w as x minus 1 times y plus 1 plus xy divided by x square plus y plus 1 whole square. Now by just looking at the denominators of this real part of w and imaginary part of w, we can see the denominators are both same, and those are nothing but x square plus y plus 1 whole square, which is always greater than 1. Sorry, which is always positive, as which are both positive terms, which since x and y are real numbers, and of course since any square of real number is again non-negative. So and sum of any two non-negative numbers is again non-negative. So we can say, since x square is non-negative and y plus 1 whole square is also non-negative, so we can say this entire term is non-negative. So hence, now to check the options, option A, real part of w greater than 0. So to check that, we'll assume or we suppose we are checking the condition if what happens if real part of w is greater than 0. So for that, I'm supposing real part of w is greater than 0, that is x times x minus 1 plus y times y plus 1 divided by x square plus y plus 1 whole square is greater than 0. So from this we can say x square minus x plus y square plus y is greater than 0. That is x square plus y square plus, okay, minus x plus y is greater than 0. This is the condition we derive when we assume real part of w is greater than 0. This we have to check whether this condition is true or false. When the given condition is real part of z plus imaginary part of z is greater than 0, that is nothing but whenever x plus y is greater than 0, thus this condition holds or not. If this condition holds, then we can say the numerator is always greater than 0, and hence the total expression when we divide with x square plus y plus 1 whole square is always greater than 0. But when the given condition x plus y greater than 0. So for that is x square plus y square minus x plus y is greater than 0 for let me write clearly to, to check real part of w is greater than 0, we need to check is whether this expression is greater than 0 or not for x plus y is greater than 0. For this, I'm just simply taking the condition to just make this condition wrong. I'm just looking for the values of x and y simply so that the values of x and y should satisfy this condition, and that should that should contradict this statement, this condition. So for that, we take the values x equal to 1 and y equal to 0. In that case, we get, then of course x plus y that is 1 always obviously greater than 0, but x square plus y square minus x plus y, this is nothing but 1 minus 1 that is equal to 0, which is not greater than 0. It is equal to 0. So we can say for z as the complex number which we assume x plus iy with the values which we assume the values of x and y as 1. In C we have real part of w is not greater than 0. So we can say option A is wrong, since for this complex number satisfying the condition x plus y greater than 0, it is not holding that real part of w is greater than 0. So we can say option A is wrong. Similarly, for imaginary part of w, that is which we derived x minus 1 times y plus 1 plus xy divided by x square plus y plus 1 whole square. We take the same values x equal to 1 and y equal to 0, the same complex number. Then we get x minus 1 times y plus 1 plus xy, which is nothing but again 0, which is not greater than 0. So we can say for the complex number z as x plus iy, which is 1. In C, imaginary part of w is not greater than 0. Of course, we have the condition x plus y greater than 0, since that is nothing but from this complex number 1. So we can say for the complex number z equal to 1, both imaginary part, both real part of z, sorry, real part of w greater than, not greater than 0, and imaginary part of w is also not greater than 0. So options A and B are wrong. So now to check out the options C and D, if we consider the same value or from the given function z plus from the given function, we can directly say from the numerator you can see it is nothing but z minus 1 divided by z plus I. So just to make this function 0, we can find the value, we can look at the zeros of this function, that is nothing but the value z equal to 1. And of course, that condition z equal to 1, that complex number satisfies the given condition, real part of z plus imaginary part of z greater than 0. So we can say at that point z equal to 1, we have the value of w is 0, that since z equal to 1 is the 0 of this function. And of course, and since that function, sorry, that complex number lie in this region, real part of z plus imaginary part of z 0, we can say for z equal to 1, we have w equal to 0, and so mod w equal to 0, which is less than 1. So we have for z equal to x plus iy, that is 1. In C, we have mod w is less than 1, but mod w is not greater than 1 from particularly for this complex number. So we can say, so which option is wrong? Option C is also wrong with this example. So option C is wrong. So hence the only option we remain with is option D. So option D is the correct answer.